So hello my dear students, I welcome to Chendu biology classes. So today I will be discussing about IIT JAM biotechnology 2026 and particularly about chemistry part. Okay, so from now onwards this is the first lecture for chemistry IIT JAM biotechnology syllabus. Okay, so now I just wanted to give you some clarity over the syllabus of this chemistry part in this biotechnology. Okay, and later on I will be showing you few questions, how and what kind of questions they are giving from chemistry part and how can you approach them, how can you like start your preparation with respect to the question pattern of questions they are asking in the exam. Okay, so first of all, this is a syllabus that is given in the like IIT JAM official prospect. Okay, so what they have given in the first chapter, it is structure and the properties of atoms. So here we need to like discuss about Bohr theory and the next periodicity in properties. Okay, so after studying this, then second chapter we have from chemical bonding. So I suggest you to strictly bind to the syllabus that they have given in the IIT JAM syllabus. Okay, see here we have complete periodic table and classification of elements, all those things are there if you take any chemistry book, but I suggest you to focus only on whatever the line they have specified here. So even if you observe the questions are purely from this particular topic only, like properties, periodicity in properties. Okay, I will tell you and I will show you the questions also. And then next chemical bonding, we have bonding in molecules. Again focus on what are the important aspects they have mentioned here. Okay, so just I wanted to tell you that you need to have some clarity over the syllabus they have mentioned. Either it can be PCM, any of the subject, physics, chemistry and maths. Okay, and this is from organic part and this is from physical chemistry part. Okay, yeah, this is from spectroscopy part. Okay, now I just wanted to begin with this first lesson, I mean periodicity in properties. It means what? Periodic table and classification of elements that you have studied in your class 12 as well as any BSc student who is having chemistry as a part of their syllabus. There you might be seen those topics. Okay, if not, I am going to give you it from very basic. Okay, so just follow the session. So now these are the number of questions that are appeared in the previous exams from the each of the chapter. Okay, so just take a screenshot, it might be useful for your analysis purpose. Okay, now I just wanted to show you what kind of questions you can see in the exam. See NEET CBC, this was IIT JAM 2025 paper if you see. So this is the question asked from this particular chapter. This is from what? IIT JAM 2025 paper you can see. So this is the official paper I have collected. From that I have collected this question. See the correct order of electronegativities of elements. Okay, so this is a very basic question. Even a 10th standard student who is having an idea over chemistry can easily answer this question. Okay, so do not scare by looking at the syllabus of this chemistry. Okay, because after your biology part, chemistry is the highest weightage topic, I mean syllabus that you have. Okay, so I am going to give you crisp, clear idea about the syllabus and the preparation strategies and everything. So just follow. So this is another question from the same topic, I mean same chapter. Arrange the following elements in the order of their electronegativity. See, same question, electronegativity, here also electronegativity. It means you can see this is 2023. Okay, so the next question if you see, again which of the following statement is not correct. See, they are asking about atomic size, ionization energy, electron affinity, electronegativity. So these are the periodic properties of the elements that we should study from the periodic table. How these properties varies in the periodic table, that is what the thing you need to be discussed here. Now I will be going to discuss every topic here. This is which are appeared in the exam, and at the final stage I am going to provide you just one page of shortcut. How can you remember these properties and all? Everything will be given here. Just look at these questions. See, again they are asking about ionic radii. Very easy questions these are. Okay, again 2023 only. Okay, again from 2013 you can see See, ionic sizes which is having smallest size, largest size, that is what we need to identify here. Very easy questions. Okay, again see here, first ionization energy, very easy question. I will tell you how can you come across this, how to tackle this. Now, in order to boost up your preparation, I have one more suggestion for you. So that is what, here just look at the NEET or JEE questions from this particular chapter. See, periodic properties, if you consider, see there you have seen ionization energy topic. Yes, so here it is about AEP set, or you can take any of the plus 12th syllabus having any engineering exams or medical entrance exams. So there you will be having ionization energy based questions, so that you can get some clarity. Isoelectronic species. Okay, so I will be showing you few more questions that are related to this. Look at here, based on their ionization energies by looking at their electronic configuration. So if you solve this kind of questions also, related questions, you will get more clarity and more confident over this syllabus of chemistry. Okay, so now, yeah, so now I will be beginning this session by showing you this periodic table. So now how many elements are there in this periodic table? We have 118 elements are there, and this periodic table is classified into 4 blocks. What are those 4 blocks? Here we have, see, this first 2 lines which you are seeing is considered as S block, and this side it is considered as P block, and this middle portion from 3 to 12, this is considered as D block, and this bottom 2 lines are considered as F block. I hope this is a basic idea everyone might be having right now. So in S block, how many groups are there? So what is this groups? So in complete periodic table, you have 18 vertical columns like this. If you count 1, 2, 3, something like this, how many you have? 18. So 18 vertical columns are called groups. So in the periodic table, how many we have groups? 18 groups are there. How many periods are there? So periods means these horizontal lines. How many are there? So 1, 2, 3 like that, you have 7. So this is the point you need to remember, basic one. 18 groups, 7 periods in the periodic table. Okay. Now, how many groups belongs to S block? See, these are the first 2 belongs to what? S block. Okay. Yeah. So these 2 are what? S block. Okay. And this 13 to 18. So these are what? P block. And this middle one is what? D block. And this bottom portions are F block. Okay. So now what are the group numbers? 1, 2 for S block, and from 13 to 18 P block, like that you need to remember. Okay. Next thing is, I am going to ask you one question. Where this, what is the group number and period number of this F block elements? See, these F block elements you are seeing at the bottom of this periodic table belongs to this cerium here you are seeing now. So these are called, the first line is called lanthanides. What is that? Lanthanides. And second series of elements are called actinides. Okay, what is that? Actinides. Okay, so now this cerium, these elements are there now. So these belongs to this particular group. It means which group it is? Third group of this periodic table. So lanthanides, actinides belongs to which group? Third group of this periodic table. This is a basic thing you need to remember. Okay, and the next thing is what? Which period this lanthanides belongs to? See, they are lying in this 6th period, and this actinides will follow this actinum element. Okay, so which period it is? 7th period. This is a basic understanding of the periodic table. Now what they are going to ask you? See, here these are alkali metals, alkaline earth metals I am saying. What is this? Alkali metals, alkaline earth metals. And so if we move this side, these are also metals. Okay, as we move this side from here to here, from S to P, so metals, and these are what? Non-metals. So I can say from moving from S block to P block, what happens? Metallic nature decreases. What is that? Metallic nature decreases. So here we have metals. As we move this side, see, there is a series of elements like pale yellow color if you observe. So those are metalloids. What is that? Metalloids. So metalloids will be having intermediate properties between metals and non-metals. Okay. So this side we have non-metals. These are metals which is separated by metalloids. This is a basic understanding you should have. Okay, then next, yeah. So the next, let us move forward. Yeah, so now they will be asking you, for example, they might give one element. For example, they will give one element like carbon. What is the atomic number of carbon? It's a basic thing. So I suggest you to learn at least 1 to 30 elements like hydrogen, helium, lithium, beryllium, like that, up to at least 30, and writing their electronic configuration. So carbon atomic number is 6. Okay. So now what is its electronic configuration? So instead we can say like this: 1s2, 2s2, atomic number is 6 now. So 2 electrons in each orbital should be filled. So 1s2, 2s2, 2p2. So total electrons are how many? 6 are there. So like this we need to write. So now for this carbon, they will give you carbon. They may ask you to identify carbon belongs to which group or which block, like that. See, you just need to identify its block. I told now how many blocks are there? 4 blocks. What are those? S, P, D, F. Okay. So now carbon, see, the last electron enters into which orbital? Yes, last electron enters into p orbital. No? So it belongs to p block. Carbon belongs to p block, you should say. Next, what is a period number, they will ask. So period number is nothing but maximum principal quantum number. What is the maximum principal quantum number? Here we have these coefficients are there now, something like ns you are writing, np you are writing, like this. This coefficient is there now. That is what? The principal quantum number. What is that? By looking at that number, consider highest number, that will be its period number. So what is the period number of this carbon? 2. So it belongs to, carbon belongs to p block, first thing, and second thing is second period. Okay, and the next thing is which group exactly, which group I am asking. So now for S and P block, just count, for S block you just count number of valency electrons. See, first you got block now, so which block it is? P block. For P block, what you need to do is number of valency electrons plus 10. It means valency means what? The highest n value is what? 2 we know. Principal quantum number 2 you told no, second period. So how many electrons are there in this? 2 plus 2, 4 na? So 4 plus p block element na, so 10. So it means which group element, group element it is? 14th group element. What is that? 14th group element. Hope it is also clear, right? Next thing is, yeah, this is about the finding block, period, group. Okay, now as a homework, small question you can take. Tell me for oxygen, which group, which block, which period? For oxygen and also for chlorine. So will you try for oxygen now itself? Yes, try it fast. So what is the atomic number of oxygen? 8. So write electronic configuration. So write 1s2, 2s2, 2p. See, out of 8, 4 is over. So remaining 4 we can write here now. So maximum p orbital can accommodate of, p subshell can accommodate of 6. So it cannot exceed 6. So you can write 4 completely over. So now what is the block it has? Last electron enter into P. So P block. And what about period? 2. And what about group? Group. See, period, see here are there now. So valency electrons are this many are there, 6. So 6 plus 10, 16th group. Is that clear? Next, so sir, why do we taking 10? You might be having this question. See, generally you can directly answer it as 6A group normally, but we know that IUPAC standard naming is there na. As per them, they have mentioned, if you look at this, they have mentioned the numbering from 1 to 18. Normally Moseley's periodic table, Mendeleev periodic table if we consider, so they will mention like these are A, these are also A, these are as B, like 1A, 2A, 3A, 4A, 5A, 6A. See, oxygen we are getting 6A, that is fine, whatever the number you got, that is fine, but as per IUPAC it should be 16. Why this 16? See, in between this we have 10 D block elements are there. So this number you are just adding there, that 6 plus 10, that's it. Okay? Yeah. Yeah. So now we need to study about properties. So what are the important properties we have? One is atomic radius, and the next electronegativity, and the next ionization energy, and the next electron affinity. These are the 4 things they may raise the question as per the previous year data. Okay? So now properties of elements, first one is atomic radius. So we have this many elements now, we have seen in the periodic table just now. So now how this atomic radius changes, this is what we need to know. Okay. Now let me go here. See, in the periodic table I just now told you that this side is metals and here it is from moving from S block to P block, metallic nature decreases and non-metallic nature, this is also one property that should be clear, it is clear now. Next thing is, what happens when we move from left to right or right to left or top to bottom to the size of these elements. This kind of questions you may see in the exam. Now I am going to explain this. See, metals, metalloids, non-metals, the different types are there now. So now this atomic radius is also given in terms of metallic radius or in terms of some other things, that is what covalent radius we can say. For metals we should express their radius in terms of metallic radius. See, we know generally you consider whatever you know, metals are there now, they are very rigid, right now they are very rigid, they can't like decompose into one another, I can say, right now they can't merge into one another, they will be very rigid, they will be like this, yes or no. So now this is one metal, this is another metal atom, you can consider, they will be like side to side but they can't merge into one another, something like this. Will they go like this? If two metal atoms, if you keep side to side, will they go like this? No, no. So this is the way to represent metals. Okay. What is mean by radius? From center to the edge. This, like this, na? So from here also we have covalent radius, and for van der Waal, the atoms are not close to each other, they have some gap in between. Okay. So 3 types of radius is there. So one is van der Waal radius, another one is metallic, another one is covalent. Out of this, which radius is maximum? See, the distance is maximum between these two. So this is van der Waal radius. Okay. So then next this is metallic radius. And what about this? Covalent radius. So tell me which is maximum? Van der Waal distance is more, so van der Waal, after this metallic, and least is covalent. This is the basic way of understanding of different types of radius. Okay. So now I am saying that the last group elements are there in the periodic table. What are the last group elements? 18th group. What are those? Which gases? Noble gases we say, or inert gases we say. See, their radius is expressed in terms of van der Waal radius. So we know which elements are having like which kind of radius is having maximum value? Van der Waals. It means in respective periods, as we move in this horizontal rows, which elements will be having maximum radius? Noble gases. So keep them aside. Always you can consider van der Waal radius. For noble gases we are expressing in terms of van der Waal, so their radius will be maximum. So keep aside. Now we will study about the remaining elements. It means from 1st to 17th. Okay. So now what exactly the radius means? It is the distance. For example, if this is an atom this is a nucleus, let us say, okay. The distance between the center, that is nucleus, to the outermost shell of that particular atom, or the highest electron cloud of that particular atom is called what? Radius. Okay. So now I am taking this atom like this. Okay. So let us say this is shell. So if you are struggling what to mean by shell, I will give you little more clarity on this. This is a nucleus, okay, and these are electron clouds. What I am saying now? Electron clouds. So atom center part contains, this red color represents what? Nucleus. Nucleus contains neutrons plus protons. Again these are positive charge, these are no charge, and around this protons we have electrons, that is what electron cloud I am saying. So now electrons will be having negative charge, we know this. Now around these protons, what I am saying, this nucleus, electrons are revolving, that is what electron cloud I am indicating. So some of them have less electron density, some of them have more. So it means electron cloud may be this much, or it can be this much, or it can be bigger also, right now. So now if I compare the distance from here to here, this is R1, let us say, this is R2, this is R3. As we move away, this electron cloud is expanding, means radius is also bigger, right now, increasing. So now as number of electrons increases, what you are feeling generally? Size also increases. This is what the conclusion we can get from this. So now little more, let us understand this little more by looking into the atoms. Now tell me, what are the elements present in second period of the periodic table? If you see this periodic table, what are the elements are there in the second period? See, this is the second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, like this we have now. Yeah. So those elements I just wanted to take here. Tell me. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So these elements are belongs to atomic number 3, 4, 5, 6, 7, 8, 9. So atomic number is this much, means it has like that many number of protons, that many number of electrons in it. So as we see, electrons are increasing, means like roughly you will consider that if electrons increases, size also, electron cloud also increases, but this is not the case here. Why? Because what is its electronic configuration we are writing? 1s2, 2s1, and for this 1s2, 2s2, for this 2s2, 2p1, like 1s2 is fixed. I am not going to write that here. Okay, so this is 2s2, 2p2, for this 2s2, 2p3, for this 2s2, 4, for this so now why I have written this many times? Because you might get some practice over this. Okay, so now if you look, the extra electron, that incoming electron, see here 1, 2, 3, this new electron is added to same energy level or same nth level. Look at the principal quantum numbers, this n values, like ns, np we are writing now, their n values are being same in all the cases. It means that electron is entering into the same shell. It means, for example, here I have written this many circles now. So those are not circles actually. So you can consider this is n equals to 1, this is n equals to 2, n equals to 3. So as we move from here to here, all of them have same n value. What is that n value? 2. It means all the electrons will goes into this second energy level only, right now. So they are going into second energy level, and number of protons inside the nucleus, protons inside the nucleus is increasing now, atomic number is increasing, means protons increasing. So positive charge inside the nucleus is increasing. It means that positively charged will strongly bind that electrons towards itself from this second energy shell, right now. So it means what happens to its size? Size compresses like this, right now. So it means from left to right, what happens as you move from S block to P block? What happens to the size? Decreases or increases? Decreases or increases? See, size shrinks now. Why it is? Positive charge increasing means that size shrinks. I mean decreases. So from left to right or from S to P, size decreases. So which is having maximum size here? Like this can we write? Yes. Now I am going to show you the values also. Okay, this is about period. What is this? Across the period or along the period. Now we need to discuss about down the group. So what do we mean by down the group? Let us say alkali metals we have. What are the elements? Lithium, sodium, potassium, rubidium, cesium, francium, like this we have. Okay. Now if you consider this many elements, so down the group, what is the electronic configuration for this? See here we have written 2s1. Okay. So now for elements of particular group will have similar electronic configuration. It means this 2 is there na, so just change this number, remaining will same, like 3s. So what is the general electronic configuration for this first group? ns1. So for this it will be, for this 6s1. So as we move down the group of this first period elements, what happens to its n value? So what is this n I told you? This is nothing but this energy numbers, shell numbers I told you, right? So this is n equals to 1, it means this is a distance. So if n equals to 2, see distance is increasing. If n equals to 3, size is increasing now. So down the group what happens to the atomic radius? So which is having maximum size? Cesium. So write cesium, rubidium, potassium, sodium, lithium. This is the order. Is that clear or not?
Sir,
Only
why does the atomic radius increases going down the group?
that is what, see, inside the nucleus protons are increasing, new electrons are also adding same number of electrons, but they are entering into which orbital or which shell? See, electron number count is increasing, but they are going into new energy level, new nth level. See, n value is increasing means first n equals to 1 means this is the n value, 2 means this one, 3, 4, like this. See, size is increasing or not? I mean electron cloud you can consider, this is the electron cloud. From here to here distance is more or not? So radius? Yes. Clear or not? Yeah. So now, yeah. So if any of the student is feeling that the class is really repeated, so why I am doing like this means there are few students who is out of this chemistry world. They might be left this chemistry after the 12th. So I just wanted to make them recall everything, or I just wanted to make them comfortable in the class. This is what my main motto here. Okay. Now if the session is going really well, just write your feedback in the chat box, or you can click on the like button. Okay. So you can feel free to express your concerns here. Yeah. Next thing is, yeah. So for the same thing, what are the two lines I told you? Across the period, atomic radius decreases. Down the group, increases. These are the two lines you need to remember. Now look at the values. See, what are these elements? Belongs to which group or which period? What? Second period elements these are. So down the group if you see, size is getting lowered. So if you want, you can check their values also like this. Values are decreasing or not? Similar story applicable for third period also. Like this, size is decreasing. Clear or not? Yes. Let me go for group. See, these are alkali metals we have discussed. So down the group what happens to the atomic radius? Increases. See, the graph is going something like upside, means this is atomic radius, atomic number, so it is going like this. It means increasing. For halogens also you can see, size is going up, I mean radius is increasing. Down the group if you move. Clear or not? Yes. Next, similar to atomic radius, we have ionic radius. So what is the ionic? See, for example, I have an atom A. If I add one electrons to this atom A, I am adding one electron, adding one electron. So it becomes what? A minus. If I remove one electron, I am removing one electron, so it should become A plus. So now tell me what is the size, first of all, what is the size of these three species which is having larger, minimum, maximum, intermediate. See, if you observe this, more the electrons, more is the electron cloud now. So more is the electron cloud means more is the distance from nucleus to that electron cloud. So which is having maximum size? Size. A minus, A plus. Okay, this is clear now? These are the two ions. Okay, anion, this is positive charge, cation, negative charge, anion. Okay, so now removal of electron from an atom results in the formation of cation, or by gain of one electron of an atom by an atom forms anion. Like this you can understand. Now the size or the radius of these ions are considered to be ionic radius. Okay, so now generally what type of question you can expect from this concept is, they will give some species called isoelectronic species. Means what? Iso means same, electronic, same number of electrons containing species are called isoelectronic species. Okay, so now they will give something like O minus 2, F minus, next we have something like sodium plus and Mg plus 2. Okay, tell me, based on the understanding from these you can answer directly answer this also. So tell me how many electrons are there here? Total electrons, O minus 2 means oxygen atomic number is 8, minus 2 means added 2 more electrons, so 10. Here fluorine 9, 1 electron added. Sodium number 11, remove 1 electron so that it becomes unipositive, 10. Here 12 minus 2 electrons you are removed so that it getting plus 2, so 10. So can I say this a species as isoelectronic species? Yes. Now we need to compare their sizes. Tell me which is having larger, which is having smaller. Arrange them in the order. Yeah, so all of them have negative charge, like same number of electrons, but what I told you, for a species having more positive charge or more nuclear force, see this positive charge is more. What happens to this electron cloud? If positive charge is more, this electron cloud is strongly attracted towards it now. So what happens to its size? Small, right now? So here more positive charge, more nuclear force of attraction, so smaller the size. And here more electron density, more electron cloud is expanded, so size is larger for. So this is the order. One last statement here you can remember for this: nuclear charge inversely proportional to its size, or size is inversely proportional to nuclear charge. NC means positive charge, you can say. More positive charge, smaller is the size. This is enough to answer this kind of questions. Okay, so that at least that whatever the last lines or last conclusions we are making for each of the discussion, just note them, it is useful. Okay, so now I am giving you one more question. So tell me, what is the size of these two? Smaller one, larger one, like that. Ionic size or ionic radii. So what is the first point I told you? Like try to remember up to first 30 elements. Then you don't need to waste time like this. Okay, so its atomic number is 16 and it is 17. Minus 2 means you add 2 electrons, 18 electrons here, minus 1 means add 1 electron, 18 electrons here. So those are isoelectronic. Now tell me, both are isoelectronic, both are having negative charge, but more negative charge, more electron density, more is the electron cloud expansion, so radius will be more. Is that clear or not? Any confusions are there? You can see ma, if they are isoelectronic species, more is the negative charge, larger is its size. More is the positive charge, smaller is its size. Now tell me. That's it, nothing to discuss here. Now tell me, n minus
Down meaning across the period, size decreases.
huh.
If you take that concept.
But these are not atoms now. These are not atoms, these are ions.
But they have the same number of electrons.
No, no, how same when you have 16 and 17 electrons, then you compare. For sulfur, chlorine, now you compare. Apply that concept. But here the story is different. 18 electron, their atomic number is 16, but it is having 18 electron. That story you won't apply here. Clear na? Got the difference? Now tell me, n minus 3, n minus 2, n minus 1, n. So tell me what is their size orders? Very basic. Okay. Now like this or like this? First case or second case? Clear. Already discussed here. Yeah. Next. Huh? Why you are getting confused again? More positive charge, see, more positive charge, smaller the size. Okay, next. Next. So everything is clear about this ionic. Okay, now tell me answer for this. See, do not think that this is neat question. I will show you. These questions are more difficult than your biotechnology, chemistry part questions. In some cases. Yes, tell me. Correct order of decreasing order of atomic radius from lithium to carbon. Already discussed in na? Yeah. We'll discuss about ionic radius. Let me check, is there any other question we have? Tell me your IIT JAM BT question. From where these elements are from? Belongs to which group? That's what. Try to get some overview of this periodic table in your mind all the time when you are solving chemistry questions. First group, I have written lithium, sodium, potassium, rubidium, cesium, I have told you. Now, they haven't given the atoms, but what you know about atomic size down the group? Down the group, size increases, we discussed. See, atoms are like this. Similar ions are formed from this Li plus, Na plus, K plus, Rb plus, Cs plus. So now tell me what happens. Here also story same, no? Because same number of electrons are removed. 1 electron is removed. So it means down the group size, what happens? Increases only. Same story, whatever you studied there, apply. Okay. So tell me what is their size? What they are among the number of ions having ionic radii more than Na plus. What are those? Na more than Na plus. That's it. That's it. Potassium, rubidium, cesium. Easy only, na? Yeah. Done with this? Yeah. Let's move forward. Next, what about this? ions with the highest and lowest, lowest and highest. So tell me lowest, lowest and highest. So I told you more negative charge, more is the electron cloud, more is its size. More positive charge, more nuclear charge, smaller the size. So this is a basic one. Nc, nuclear charge inversely proportional to size. More nuclear charge for aluminum, Al plus 3, so smaller size. So what is the order we can get? Al plus 3 smaller, then Mg plus 2, then F minus, O minus 2. So highest one is for O minus, lowest one is for Al plus 3. That's it. Do we have any option? No, sorry. One is perfect. Okay, clear now? Yeah. Yeah. So now whatever the questions asked previously, it is covered. Now we need to study the other topics mentioned. So let us discuss about ionization energy. So what exactly ionization energy mean? See, name itself saying na ionization. For example, I have an atom A, I need to ionize it. I need to ionize this atom. So how this ionization taking place? By removing one electron. By removing electrons, I can say. So it can become A plus. This is atom, this is ion. By what process? By removing one electron. Okay. So now there is a proper definition for this. Okay. See, the minimum amount of energy that is required to remove electron from outermost orbit of an isolated gaseous atom. It means whatever the atom you are taking, that should be in the gaseous state. It means if it is in metallic state, for example, solid state, you need to convert into gaseous state, and that should be not in combined form, it should be isolated one. Like it should not be like A2, something like that. It should be single individual isolated atom. Okay, see, the minimum amount of energy required to remove from neutral gaseous isolated atom to make this process, to remove one electron, it is becoming like this. So the energy included in this what? Ionization energy. Now we have successive ionization energy. It means what? First electron we have removed now. This is ionization energy 1, IE1. If we remove second electron, so from here we are removing now. So it becomes A plus 2 and 1 electron is removed. So this is what? 2, like that. If we remove one more, IE3, so like that. See, M, so this is what? Second electron, third electron, third ionization energy. Now if we compare IE1, IE2, IE3, it means what? First, second, third ionization energy, like successive ionization energy. Which is maximum? Last one will be maximum. It means, see, first of all tell me, here I have positive charge, nucleus, around here we have electrons, let us say. This valency electron only we are removing first. Now tell me, this positive charge will hold this electron strongly now, because both are oppositely charged, so they will have some intermolecular like electronic attractions are there, so attractive forces are there. So it means there is some force attracting that electrons inside. Now in order to remove that electron, consider it an electron, in order to remove this electron we need to use some external energy. See, I am using some energy to remove this electron like this, right now. So are we supplying the energy, or this process is releasing the energy? Supplying. So that energy is supplied now, we are using energy, required energy we are saying, minimum amount of energy required we are saying. So we are using energy, so we should call it as endothermic process. What is that? You know now, endothermic, exothermic, these things. So ionization energy is what? Endothermic process. Means positive or negative? Positive. So delta H I is positive. I can indicate like this. Now I want to compare IE1, IE2, IE3 for a process. So tell me which is maximum? which is maximum? Why IE3? See, first of all we are removing one electron from neutral one, that is fine. But here if you see the positive charge, more nuclear charge is increasing now. Electron count decreasing means nuclear charge will be effective here. So strongly, electrons are strongly attracted towards nucleus as it is becoming positive. So now it requires more amount of energy. Right now like that, as positive charge increases, they will strongly bind to the nucleus, electrons strongly bind to the nucleus, so energy will be more. So that's why IE3 is more than IE2 than IE1. This is a basic understanding. Okay, so here I have mentioned. Next thing is how this ionization varies across the period or along the group or down the group. Okay, that is what we need. Variation along a period. So in a period, the value of ionization enthalpy increases from left to right. It means from S to P block if we move. What happens to ionization energy? Left to right they are saying now, from here to here. So they are saying it increases, okay, but there are some breaks. See, which breaks where the atom have some what stable electronic configuration. It means there is a factor deciding ionization energy values. What is that factor? Its electronic configuration is also matters. Okay, I will show you that. Okay, about the variation in groups we will discuss tomorrow. I just want to wind up at this period itself. Okay, so now tell me what are the elements of second period. Again we will take second period elements. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and let us write neon also. Okay, so now what is the electronic configuration? Fast. 1, 2s, 2. This is 2s2, 2p1. This is 2s2, 2p2. For this 2p3. P6. Now tell me, we know that last element which is having fully filled electronic configuration is highly stable now. So in order to remove electron from here is very difficult. Yes or no? Because it is fully filled, it is strongly bind to the nucleus. So which is having highest ionization energy in the periodic table? I mean noble gases, right now. So in any group, noble gases will be having highest. After this, we know fluorine is more electronegative atom that required one more electron to see. This fellow required 5 electrons are there. One more electron is required to acquire this stable configuration. Now they have high tendency to gain one electron. So that's why they have tendency to gain the electron but not to lose. But ionization energy means losing the energy. But they have tendency to gain. So they have very less like ability to lose the electron. So I can say required more amount of energy to remove this electron. No? So after that fluorine. Now look here, between these two things, here we have 2p4, 2p3. So now how many p orbitals are there? S orbital is 1, p orbitals are 3 like this. So wherever you are seeing half filled configuration like this in p or full filled configuration like this, like either it should have 6 or it should have 3, are considered to be stable. Now see here how many electrons are there? 3, and here 4, which is having half filled nitrogen. So stable configuration is for nitrogen when we compare with the oxygen. So now tell me, removal of electron is difficult from the stable configuration. Therefore nitrogen will have more ionization energy value when compared with the oxygen. So what I should write here? N, after that O. Is it clear? Yeah. So that is what here I mentioned, which breaks where it has stable electronic configuration. After that, between carbon and boron, carbon. Next, boron and beryllium, beryllium. Why beryllium? 2s2 it has 2p1 the boron is having, it is easily removed, becomes 2s2. Here also by removing it becomes 2p3 stable electronic configuration. Okay, so I can say out of these two, the main reason you should say is penetrating capacity. There is a word called penetrating capacity of s orbital is more when we compare with the p orbital. So what is this PC penetrating capacity means? See, if this is the nucleus, around that we have sp orbitals like that now. So s orbital is in spherical in shape, p orbital will be in like dumbbell shape. So which is very close or which is symmetric around the nucleus? S or P? S. It means the s orbital will be more effectively binds to the nucleus. Therefore, removal of electron from S is difficult when we compare with the P. This is how you can understand that word penetrating capacity here. Okay? If they won't ask you, even if they ask, should answer in this way. Okay? Next, here I should write beryllium, next boron, and least is lithium, because only one electron na easy to remove. Okay? So least is alkali metals. In every period, least is for alkali metal, highest is for noble gases. After that, halogens. Okay, remember this same story you can apply for third period elements. These are for, so you can give me your order for third period elements, just give a try and you can check it. Okay, remaining things we will discuss in the next session. Okay, yeah, what are the things we discussed? I want a quick revision. Basic things about periodic table, how the trends varies I told you, what are the elements we have, yes, electronic configuration, a brief introduction, then next atomic radius, ionic radius, ionization energy, and questions related to that, that's it. Okay, and any doubts are there, you can feel free to ask and you can meet me after the class also. Thank you.